Hey young engineers, and welcome back to the channel. Today is the day we've all been waiting for. We've built some incredible things together, haven't we? We made hovercrafts that glide on a cushion of air, balloon rockets that blasted off into the sky, rubber band cars that raced across the floor, and pulley systems that lifted heavy loads with ease. Each one was a super fun project on its own, teaching us a little something about physics and engineering. But what if we took all that knowledge, all those skills we've learned, and combined them into one epic, ultimate, mega challenge? Well, that's exactly what we're doing today. Welcome to the Gadget Lab. This is where we put everything we've learned to the test. We're going to experiment, we're going to build, we're going to tweak, and we're going to watch physics come alive in a whole new way. By the end of this video, you won't just have one cool gadget. You'll have your very own mini gadget lab, full of amazing inventions you created yourself. So are you ready to become a master gadgeteer? Let's get started. First up, let's gather our materials for our gadget lab headquarters. We'll need a mix of things we've used before. Grab some cardboard, a few balloons, rubber bands, plastic bottles, discs or bottle caps for wheels, straws, skewers or chopsticks for axles, and some string. Oh, and don't forget the essentials: scissors, a hot glue gun with plenty of glue sticks, and make sure to ask a grown-up for help with that, and some tape. This is our inventor's toolkit. The beauty of the Gadget Lab is that there are no strict rules, only principles. The goal is to innovate and combine ideas. Let's start by revisiting our first invention, the hovercraft. Remember how we used a balloon and a bottle cap to create a cushion of air that let a CD float? That was all about air pressure. Now, how can we upgrade this? Instead of just letting it hover, what if we gave it a way to move on its own? This is where our second project, the balloon rocket, comes in. Let's build a basic hovercraft first. Take a pop-top bottle cap, glue it over the hole of an old CD, making sure it's airtight. Now blow up a balloon, pinch the neck, and stretch it over the bottle cap. Pop the top open and whoosh, it hovers. Classic. But we're not stopping there. Now for the Gadget Lab upgrade. Let's give our hovercraft a propulsion system. Grab another balloon. Instead of using it for lift, we're going to use it for thrust. Tape a straw to the side of your CD. Now, blow up the second balloon, pinch it closed, and tape the neck of the balloon securely around one end of the straw. Make sure the straw is pointing straight back behind the hovercraft. So now you have one balloon on top for lift and one balloon on the back for thrust. Let's try it. First, inflate the top balloon and pop the cap to get it hovering. Now, let go of the second balloon. Look at that. It's a self-propelled hovercraft. You've just combined two different principles: air pressure for lift and Newton's third law of motion for thrust. For every action, there is an equal and opposite reaction. The air rushing out of the back balloon pushes the hovercraft forward. How cool is that? But wait, the Gadget Lab challenge is just getting started. What if our hovercraft needs to navigate a tricky obstacle course? What if it needs to turn? This is where we bring in our third project, the rubber band car. Remember how we used the stored potential energy in a twisted rubber band to power our cars? We can adapt that idea to create a steering mechanism. Let's try this. We need to build a small, lightweight rudder for our hovercraft. Cut a small rectangle out of cardboard, maybe about the size of your thumb. Now, let's attach this rudder to the back of our hovercraft. You could tape it to the end of the propulsion straw. But how do we control it? This is where the rubber bands come in. We can create a simple tension system. Let's tape one rubber band to the left side of the rudder and another to the right. Stretch these rubber bands forward and tape them to the sides of the CD. Now, the rudder is held in the middle. But if you gently pull one of the rubber bands, you can change the angle of the rudder. When your propelled hovercraft is moving, this rudder will direct the flow of air, allowing you to steer it. It's a bit tricky, but that's what experimenting is all about. You've just added a control system to your vehicle. You're not just an engineer, you're a pilot. Try different rudder shapes and sizes. Does a taller rudder work better? What about a wider one? This is your lab, you make the rules. Okay, our hovercraft is fast, it's steerable, but what else can it do? A true gadgeteer thinks about purpose. What missions can our inventions accomplish? This brings us to our fourth and final project integration, the pulley system. Remember how we used pulleys to make lifting heavy objects feel super light? We can build a miniature crane right onto our hovercraft. Let's get a straw and secure it vertically onto our CD, like a mast on a ship. You can use a big glob of hot glue at the base to make it sturdy. Now, we need a boom arm for our crane. Another straw, or maybe a popsicle stick, attached near the top of the mast at an angle, will work perfectly. Now for the pulley itself, a small bead, a tiny Lego wheel, or even just a bent paperclip looped over the arm can work as a simple pulley. Run a piece of string over your pulley. On one end, you can tie a small hook made from another paperclip. On the other end, you can just let it hang or create a small winder to reel it in. Now, your hovercraft isn't just a vehicle, it's a mobile recovery unit. You can drive it over to a small object, like a Lego brick or a paperclip, lower your hook, and lift the payload. You've combined four different engineering concepts into one incredible machine. You have a vehicle that floats on air, propels itself with rocket power, steers with a rudder system, and can lift objects with a crane. This is the ultimate Gadget Lab creation. Now, the real fun of the Gadget Lab begins. This is just one way to combine these ideas. What if you put the pulley system on the rubber band car instead? You could have a car that drives up to a canyon, like the space between two books, and lowers a hook to rescue something from down below. Or what if you tried to make a multi-stage balloon rocket? You could have one balloon launch a smaller, lighter rocket when it runs out of air. The possibilities are absolutely endless. The whole point of the Gadget Lab is to look at the tools and principles you know and ask what if? What if I connect this to that? What if I use this part for a different purpose? Let's think about some other challenges. Can you build a rubber band car that can climb a small ramp? You might need to add more rubber bands for more power, or think about the friction on your wheels. Maybe add rubber bands around the wheels for better grip. Can you create a pulley system that can lift your own pencil case? You might need to use multiple pulleys to multiply your force. This is what real engineers do every single day. They take existing ideas, they mix them, they match them, and they create something brand new to solve a problem. And today, you've done the exact same thing. You've looked at air pressure, motion, stored energy, and mechanical advantage, and you've woven them together into your own unique inventions. You should be incredibly proud of what you've built today. Look at your desk. It's not messy, it's a laboratory. It's a space for creativity and discovery. Each piece of cardboard, every straw and rubber band is a testament to your ingenuity. Don't be afraid to take things apart and rebuild them in a new way. That's how the best inventions are born. Maybe your hover crane didn't work perfectly the first time. That's not a failure, that's data, it's information that you can use to make it better. Maybe the rudder was too heavy or the propulsion balloon was pointed the wrong way. Every problem is just a puzzle waiting to be solved. So I challenge you, young engineers, to keep your Gadget Lab open. Keep experimenting. What other simple machines can you incorporate? Levers, wedges, screws. Look around your house for inspiration. A bottle cap is a screw, a doorstop is a wedge. Science is everywhere, and now you have the skills to harness it. Take pictures or videos of your amazing Gadget Lab creations and share them in the comments below, or have your parents post them on social media. We'd love to see the incredible, innovative, and crazy contraptions you come up with. You are all officially certified Gadget Lab engineers. Thank you so much for joining me on this incredible building adventure today. It was amazing to see all our hard work come together in one ultimate project. I hope you had as much fun as I did. Remember to keep thinking, keep building, and keep asking what if? If you enjoy creating your Gadget Lab, Make sure to hit that like button and subscribe to the channel so you don't miss our next engineering challenge. Until then, stay curious.